so today we're working with this beautiful 2015 GTI Volkswagen. Check this thing out, it's looking pretty spicy, damn. Okay, so to find the centripetal force of this car doing a donut, we're gonna need an important variable, and that's mass. So to calculate that, I'm very accurate at calculations. How I do it, I lift up a vehicle, I know the mass instantly. It's a gift, all right, let's do it. Damn, okay, that's 1,383.45 kilograms. We're gonna use that later. All right, guys, so today we're gonna be measuring centripetal force. And to do that, we're gonna need a couple variables to take into account the equation m times v squared over r. So first, we're gonna need to find the velocity of this car while we are doing a donut. Let's get started. All right, rip it, turd! It's about 15 miles per hour. We'll convert that later. All right, guys, now that we've successfully done a scrumptious donut, now we need to find the diameter of this donut to figure out the velocity. So, we come over here, right? 24 feet. As you guys know, I have the power to touch something and convert it into whatever I want. So I'm going to touch this, 24 feet, 7.3 meters. All right, that's one variable we need to know.
Hey kids, Farmer John G. and Joseph here, and we're going to be finding the acceleration of this good old John Deere tractor here today. So for the first part of the video, we're going to need to find the velocity, and actually the change in velocity to be more exact. We're going to need to find the initial velocity. So for that, it's 0 because we ain't moving. Alright kids, so the next thing we ought to find is the final velocity of this good old John Deere doing a final donut. So let's figure this out, alright? Alright, so now we know that the final velocity is about 12 miles per hour, which translates into 5.3 meters per second. And the time it took, which is the last factor we need to find, to get around the donut was about 6 seconds. So we're going to be taking that and calculating the final acceleration of the car doing the donut. And it's going to be about 0.88 meters per second.
Hey guys, what's up? The name's Joseph. So today we're going to be determining the velocity of a car by distance over time. And the car we're going to be using, that GTI right there. All right. And how we're going to do it is we're going to start it from that point, and we're going to use the cement sidewalks from here to there as a finish line. And we're going to use that distance, which is 100 feet, also 30.5 meters, and we're going to time how long it takes us to get there at a constant speed. So let's do that. All right, guys, so we got Fumar here taking me on this drive, and to get to that point, which is not 100 feet away from us quite yet, we have to build up to that constant speed to make sure we're getting a proper velocity. And once we reach next to that box right there, I'll start this stopwatch. Jeez, I can't speak right now. And I'll stop it once we get to the correct point, and we'll know the time it took us to get from point A to point B. Let's go. Start. Stop. Alrighty, guys. So, we got ourselves 5.53 seconds. Let's convert this. All right, guys. So, we got from point A to point B. We did it in 5.5 seconds. And we know that the distance from here to there is 30.5 meters. So, we're going to divide 30.5 meters divided by 5.5 seconds. Now, coincidentally, that is also 5.5 meters per second. So that means the velocity at a constant speed of this car going from point A to point B is, well, 5.5 meters per second.
Yo, what's up guys? It's Fumar here, and we're gonna be finding the force of this sick, radical GTI. The first thing we need to find is the mass of that car. From previous videos, you guys should already know that. It's 1,383.45 kilograms. Alright, so the next thing we need to find is acceleration. Let's get to that. Alright guys, so for the acceleration, first we need to know the velocity, and so the initial velocity is 0, as you can tell. And let's go find the final velocity. Let's get to it.
Fumar! What was it? What was it, Fumar? What was it?
12 miles per hour! 12 miles per hour!
What does that convert to in meters per second?
5.3 meters per second. That's insane! Do you know how long it took to get from there to here?
It was only 5 seconds.
5 seconds? Well, that means 5.3 meters per second divided by 5 seconds equals 1.06 meters per second squared. That's the total acceleration. Alright, so now that we know the final acceleration, which is 1.06 meters per second squared, we're going to multiply that to the mass of this radical GTI to find the total force of the car going from A to B. And that is going to be 1,466 newtons. Eat. What's up guys, I'm Jose, the local soccer coach over at the Campbell Rec Center. I hate my life. Soccer coaching is just terrible. Worst job I've ever done. Wouldn't recommend it. But I'm just gonna find the impulse of this car driving. It's not a big deal. Alright guys, so to find the impulse we need to change in time. And to do that, we're gonna drive from A to B. But we need to replicate exactly how my brother Fumar, the exact time and the exact speed he did it. 5.3 meters per second. Hee. 5.3 meters per second. Alright guys, so now that we know the change in time was about 7 seconds, we're gonna multiply that to the total force of the car, which is 1,466 newtons. And when we multiply those together to get the total impulse, that's gonna be about 10,262 newton seconds.
Hey guys, what's up? So for our last concept, sadly, we've reached the end of the video. I know, it's very sad. But we're gonna find the kinetic energy of this car right here by finding the mass, which we already know, 1,383.45 kilograms, and the velocity, which we're gonna calculate now just by looking at the speedometer while Tyler's driving here. And so, the equation for kinetic energy is kinetic energy equals 1/2 mass times velocity squared. Let's get into it. Alright guys, we're at 10 miles per hour. We're at a constant speed. Alright guys, so one important concept I want you guys to know is always wear your seatbelts, alright? It's dangerous. Come on guys. Alright, now he's at 10 miles per hour again. I'm going to touch the speedometer. You guys know what my power is. I can convert things with my hand. That felt like 4.5 meters per second. And now we're going to calculate the kinetic energy later. Alright guys, so we're at it. We're at the end. Now, we already know that the velocity of this car at that constant speed was 4.5 meters per second. We also know the mass of the car, 1,383.45 kilograms. Now, to find the kinetic energy in joules, we have to multiply 1/2 times 1,383.45 kilograms, also multiplied by the velocity squared, 4.5 squared, and that gives us a kinetic energy of 14,007 joules. Thank you. Alright guys, it was a pleasure filming this. We hope you like it. Now we're gonna head out of here. Any last words, Tyler?
Have a good day.
The watch cost me
Very wise. Let's see you later.
bitch. Free.